Okay, in this tutorial we're going to be looking at composite functions and functional equations. So composite functions are where we have one function within another function. So it's written as f of g of x or f of g of x. Okay, so this is just with a little open dot in between the f and the g of x. Okay, so for example, if f of x equaled x squared and g of x equaled 3x take 1, then f of g of x would be 3x take 1 squared. So for f of g of x, wherever we have an x in f of x, we replace it with the entire function g of x. Okay. Similarly, we could look at g of f of x. So this time, wherever we have an x in 3x take 1, we put in x squared. Okay? So we're replacing the x's in one equation with the entirety of another equation. Okay, there's just some rules for when these things exist. Okay, so for f of g of x to exist, then the range of g of x must be a subset of the domain of f of x. So the range of this thing has to be a subset of the domain of this thing. Okay, so remember, a subset is it's going to contain points that are in the domain. So points in the range have to be points within the domain. Okay, and we find that the domain of g of x will be the domain of f of g of x. Okay, so we'll look at a couple of examples. Okay, so we're looking at work example 1. Okay, and we're saying if f of x equals e to the x, okay, and g of x equals the square root of x minus 2, investigate whether the composite function f of g of x and g of f of x exist. Okay, if they do, we've got to find a rule for them. So we're going to start with looking at f of g of x. Okay, so what we need to do is think, okay, let's make a table just to keep these things a little bit more organised. So what we usually do is do something like this. We say, well, here's f of x, here's g of x. And then put in our domain and our range. Okay, so we look at f of x first, let's say. So we look and we go, well, what's our domain of e to the x? And that's all real numbers. Okay, and if we look at our range for e to the x, it's from 0 to infinity. Okay. Then if we look at our g of x, okay, look at our domain. Now remember, because this is -2, we've been moved to the right by 2 units. So our domain then becomes from 2 to infinity. Okay, and our range is from 0 to infinity. Okay, so you need to go, is the range of g of x a subset of the domain of f of x? So is this a subset of that? And yes, it is. Okay, so f of g of x exists. Okay, therefore we can work it out. F of g of x. Okay, so wherever we've got an x here, we replace with this equation. So we're going to get e to the power of the square root of x take 2. Okay, and our domain is our domain of g of x. So we input where x is an element of 2 to infinity. Okay, now we'll have a look at g of f of x. Okay, so again, remember our range has to be a subset of our domain. And we look and we go, our range from 0 to infinity is not a subset of this. Okay, the domain of g of x would be a subset of the range of f of x, but not the other way around, which we need. We need this to be a subset of that. It's not, therefore g of f of x does not exist. Okay, we'll have a look at one other worked example. So we're saying that we've got the functions, and so this is worked example 2. So we've got the function f of x equals square root of 4 minus x. and g of x equals x minus 1. Okay, and we want to see, well, we want to start off by stating why f of g of x is not defined. Okay, we need to state why that is not defined. Okay, so the best thing to do is do a little table again. Okay, we've got f of x plus g of x. We've got our domain, and we've got our range. Okay, so our domain for f of x, okay, will be from negative infinity to 4. Okay, because we're negative x, so you can think of this as square root of negative x plus 4. Okay, so we end up need to take out the negative as a common factor, so we think of that as, so think of this function as the square root of negative x take 4. So it's been moved to the right, but it's negative, so it's been reflected. Okay, and our range will be from 0 to infinity. And for g of x, okay, we can see that our domain will be R and our domain will be R. Okay, so then we look and we need the range of g of x to be a subset of the domain, and we can quite clearly see that this is not a subset of this. Okay. Then what we need to do, okay, is restrict the domain of g of x to form a new function h of x. Okay, so that f of h of x exists. Okay, so we want to find f of h of x, so we're going to restrict this domain. Okay, so that it does work. Okay, so we need the range to be a subset of the domain. So if we just make this range, okay, be equal to this domain, then we'll be going okay. So what we want to do, okay, is do our restriction to our range. So we want x take 1 to be less than 4, because that's going to be the top of our domain. Okay, so that means that x has to be less than 5. Okay, so if we look at doing that, okay, then we say, well, h of x, which we can add to the table here, okay, if we like, is going to have a domain of negative infinity to 5, which gives us our range of negative infinity to 4. Okay, so our new function h of x will equal our x take 1, where x is an element from negative infinity to 5. Okay, and that's it. I'm sorry, not quite. We actually need to find out f of h of x. Okay, so wherever we've got x and f of x, we're going to put our h of x. So that means we're going to get the square root of 4 minus x take 1, which means we're going to end up with 5 minus x. Okay, and now we can, oh, and sorry, remember that our domain of this is going to be the domain of h of x, so I can say where x is an element of negative infinity to 5. Okay, and we'll flip over. I left a page for the page there. Oh, no, sorry. We'll use the page I meant to leave blank for our functional equations. That's okay. We'll do that over here. So functional equations. Okay, for these, what we're trying to do is prove things like f of x plus y equals f of x plus f of y. Okay, or it could be that f of x take y equals f of x over f of y. It's things like trying to prove that. Okay? And so when we're trying to prove these things, what we're doing is trying to get our left-hand side to equal our right-hand side. Okay, so we'll look at doing an equation, an example. So we have f of x equals 1 on x, and we want to see if that satisfies f of x plus f of y over f of x times y equals x plus y. Okay, that's what we're trying to do. Okay, so what we do is we start with our left hand side. Okay, and we go, okay, well, f of x, okay, is 1 on x. Okay, f of y would be 1 over y. Okay, and f of xy would be x would be 1 on xy. Okay, so we can fix that up a little bit, because we can really go, okay, well, let's make that 1 on x plus 1 on y times by xy by flipping and multiplying. Okay, and when we do that, okay, well, what we want to do is fix up in here a little bit, okay, and get our denominators the same. So we multiply this by y, that by x. So we'd have y plus x over xy times by xy. So our xy's are going to cancel out and leave us, I'll come up here, so our left hand side now equals x plus y. I've just put them back around the other way. And our right hand side, we know, equals x plus y. Okay, therefore, left hand side equals right hand side. Okay, and f of x equals 1 on x, okay, does satisfy this condition. Okay, so all we're really doing is playing around with the function that we're given, okay, to see if it does satisfy a condition. So hopefully that's enough to get you through the questions on this section.